Okay, this is section 2.2 from your book on average velocity, or is it speed? Perhaps you've used these two terms interchangeably. Even though we can get by with that occasionally, they are slightly different. Our goal in this video is to understand the differences between them and to make sure we know when to use which quantity. Story, cut versus laceration. If this were an in-person lecture, I'd probably start by sharing the story. I'm not going to do that in this video, so be sure to ask me if you want to hear about it. I'd love to share the story with you. Speed, how far an object travels in a given time interval. So average speed is just a measure of distance traveled per unit time. Velocity does include additional information. If you do know the difference between speed and velocity, could you tell me what goes in here? Velocity includes directional information. So we often say that velocity is speed with a direction. Instead of distance traveled per unit time, it's a measure of displacement per unit time. Speed can only be positive. Velocity can be negative, depends on our coordinate system. So if we define westward to be negative and we're traveling west, we might say that we have a velocity of negative 60 miles per hour. I'm not going to share the answer to this question with you on this video. Read through it, and perhaps in class I'll ask you what you think the answer is, and we'll certainly explain the result. Let's take a look at a couple of examples. The position of a runner as a function of time is plotted as moving along the x-axis of a coordinate system. During a 3-second time interval, the runner's position changes from 50 to 30.5 meters. As shown, what was the average velocity of that runner? Now, I'm going to start with the basic equation. And for this first problem, I'm going to be a little bit more explicit than I normally am, just so you make sure you see how these terms are computed. This delta, again, means difference, and the difference is a subtraction. We have to be careful of the order of subtraction. So x2 minus x1, I ended at a position of 30.5 meters, and I started at a position of 50 meters. Time interval, I ended after 3 seconds. And it doesn't say I started at 0, but we can infer that that's the case. Negative 19.5 meters of displacement in 3 seconds means we traveled with an average velocity of negative 6.5 meters per second. And again, the negative is just to denote that we're moving in the direction we call negative. Let's take a look at another example. Time for a cyclist. How long will it take a cyclist traveling at 18 kilometers per hour to travel a distance of 1,800 meters? Again, let's see, speed or velocity. I guess it has distance here. I'm going to go ahead and just say speed, distance over time. I'm going to solve that for t. For those of you that loved algebra, this is your chance to shine. Looks like I love algebra. I did that correctly. 1,800 meters of distance. The speed that they're traveling, 18 kilometers per hour. Better pay attention to those units. 18 kilometers and 1,800 meters. I've got to make sure they have the same units here to get the proper cancellation. So 18,000 meters per hour gives me a time of 0.1 hours. Probably better to put that into minutes, a little bit easier to understand. A tenth of an hour is about 6 minutes. So there we go. All right, yeah, those look like they're done solved. They're solved correctly. Let's move on to the last problem. This is to show the difference between speed and velocity. Here we have a graphic showing the ball rolling from a position of x equals 0 meters, hits a wall at 10 meters away, takes 2 seconds to do so, loses a little bit of energy off of that bounce, and travels back to a position of 7 meters after 6 seconds. Our goal here is to figure out the average speed and the average velocity of the ball over the 8 seconds of motion shown above. Let's go ahead and do that here with some quick equations. Distance over time. So they traveled 10 meters and back another 3 meters. So I'm going to go ahead and write that like this. Sometimes students see that 7 and want to do 10 plus 7, but that's a position, not a distance that they traveled. And so we've got to pay attention to that. Let's see, it takes a total of 8 seconds. And so sure enough, 13 divided by 8 is about 1.6 meters per second. And of course, that has to be positive. Average speed for that ball. Now, average velocity, displacement over time. Let's see, I started at 0, hit to 10, come back to 7. Doesn't matter the path that it takes. The displacement was 7 meters in the positive direction. I'll put that 0 in here just for completeness sake. but the displacement 7 meters in the positive direction. Time still 8 seconds. And so we get a average velocity of 0.875. Let's just go ahead and round that to 0.88 meters per second. And again, that's positive because their displacement was in the positive direction. Okay? And so there we go. Average velocity versus average speed. Clearly these are different. So there is a key takeaway. Okay, we can certainly do all the number crunching we want until we're blue in the face. But the big idea is that speed and velocity are interchangeable unless there is a change in direction. That change in direction becomes pretty important. So we'll see how that pans out as we start to study this concept called acceleration in section 2.4. But for now, let's just make sure we understand the difference between speed and velocity is that one of them includes direction, and when there is a directional change, we're going to get a different value computed for speed versus velocity. Okay, so there we go. That's section 2.2 on average velocity.